Today we are learning about growing patterns. We will learn to extend these patterns to create sequences with rules to match. Before we dive in, it's important that we understand the meaning of a few words we'll be using throughout the video.
In repeating patterns, the element that repeats itself over and over again is called the core. This is the same for growing patterns. When referring to a specific piece of the pattern, we call this the term.
Growing patterns are patterns that increase or decrease in a predictable way. When looking at growing patterns, we pay attention to relationships that allow us to identify what the pattern will be at any point along the way. The easiest way to identify a relationship is to first locate the core.
Let's take a look at this example. In this example, we can see that each term is increasing by 2, so we add 2 to each term to reach the next. 2, 4, 6, 8, 10. We call this an additive pattern. We can also have multiplicative patterns. As the pattern grows in this example, we can see that it involves multiplying each term by 2. 2, 4, 8, and 16.
Now that you have seen 2 examples, let's take a look at a more complicated pattern that combines both operations. We can see that each term is first multiplied by 2, then 2 is added. 2 times 2 is 4, and plus 2 is 6, and so on. When representing growing patterns with pictures, we are able to easily work out the rule.
Here is the snake on the first day it was born. Here is the snake on day 2. Let's pause the video and have a think about what the snake would look like on day 3. Were your thoughts correct? Now, the relationship between day 1 and 2 allows us to see the pattern. We can identify the core of the pattern as a snake's head and tail. As the snake grows, it increases by 2 triangles per day plus the outer 2 that make up the head and tail. If I wanted to work out what the snake would look like on day 8 without drawing it, how could I do this? The easiest way to work this out is if we turn this into a rule, which will allow us to generalise and identify what the pattern will be at any point along the way without the need to draw it.
To create a rule for this growing pattern, we must first identify the core. We know that the core in this pattern is the snake's head and tail, which will always automatically add 2 triangles. This will not change no matter how old the snake is because we know that the core is the element that repeats itself. Therefore, we can say that the rule to work out what our snake will look like at any given day is days born times 2 plus 2 equals amount of triangles. To make sure that our rule is correct, we can test it. For day 1, the rule would be 1 times 2 plus 2 equals 4. We can see that this is correct because there are 4 triangles in the day 1 snake. For day 2, the rule would be 2 times 2 plus 2 equals 6. We can see that there are 6 triangles in the day 2 snake.
Now let's go back to the question, how would the snake look on day 8? Using our rule, we know that the snake would have 18 triangles because 8 times 2 plus 2 is 18. We can't always rely on drawing diagrams or counting to work out the answer. We want to get confident in creating rules for growing patterns so that we can learn to generalise and begin algebraic thinking.